So I'm going to talk about hands-on activities for exploring Rosette Symmetry groups. Specifically, one is going to be on making cutouts with the aim of creating snowflakes. And then the other one, which I probably won't have too much time to talk about, is Truchet rosettes. So the background on the course, so first of all, I'm teaching at the Fashion Institute of Technology in New York City, which is a college as part of the SUNY, which is the State University of New York. And the course is called The Geometry of Art and Design. It's basically an elective, but it fulfills a math requirement or a liberal art requirement. So the students are design students, so in a variety of different fields, which makes it a lot of fun. So to give a little bit of background on this lecture, this comes after an introduction to symmetry groups, and students have already learned about dihedral and cyclic symmetry groups at this point. And we go through this flow chart to help them differentiate between the two. And then this is the first part of the activity, is creating cutouts and snowflakes. So I made a video just so I can make sure to have enough time to show you the sequence of events. But before I have students create their own cutouts, I usually show them this video, which I'm not gonna play for you because it's on YouTube. You could just watch it, but it's linked on the PowerPoint slide, which explains why snowflakes are specifically D6. So it gets into the molecular breakdown. And then I talk a little bit about this man who was famous for photographing snowflakes in the late 1800s. I've taught this class in person and then now online. In person, we work with paper and scissors, which is a lot of fun. But because I was moving online, I had to find something that, you know, if students didn't have access to paper, they could still follow along. So there's this website, onemotion.com, and it has a great app, which I'm going to demonstrate for you. Okay, so I put the time to 1.25. Tell me if it's going too fast.
Which is making cutouts and snowflakes. So you'll need some origami paper if you've got. The more patterns, the better. A scissor, a bone folder, can't hurt. And then for the discs, I just have parchment paper. You can also do this digitally using the app that I have presented on the screen. So I'll do both ways. The first question asks us to make a D1 cutout, which means we need one reflection line. So think about, we've got our paper. How are we going to get one reflection line? Well, if we fold it in half, then we're creating mirror images. And if we cut it after we fold it and open it up, we'll end up with a D1, just like you see here. So we can do this by folding along a horizontal or a vertical or along a diagonal. So here we'll do along a diagonal, and then we make some cuts. And open it up. And we see we've got a D1, so one line of reflection and the identity rotation. Next up, we'll want to make a D2, which means we want two lines of reflection. So let's start off with our same paper and fold it in half once, and then fold it in half again. Make some cuts, open it up, and lo and behold, we have a D2, so two lines of symmetry. We can also do this digitally. Here I'll fold along the diagonal just to mix it up. So that's once in half and then in half again. And this gives us 4 equal regions. So when we cut it up, we'll see we've got a D2. So 4 equal regions gives us 2 lines of symmetry. You see this has along both of the diagonals and 180-degree rotation, as well as the identity rotation. Okay, next up we have a D4. So in this case, think about how many times we would need to fold it, right? So far, to make a D1, we folded it once. To make a D2, we folded it twice. Do we need to fold it 4 times to make a D4? Maybe stop the video and think about it on your own. If you're still not sure, you can just get started and fold and see what happens. So starting off with a paper, we fold in half. And then in half again. Okay, so that was what we needed for a D2. And then let's fold in half again so we get this shape and cut it up and see what happens. Right, what you'll see is that I have 4 lines of symmetry, right? along the vertical, horizontal, and then both diagonals. So it seems like for a D4, we would need to fold 3 times. I'll also demo this using the app right in front of you. So here we go once, there is twice, and then along the diagonal. So that's 3 times. And then we can make some cuts. And open it up, and you see we've got a D4, 4 lines of reflection and 90-degree rotation. Okay, so now let's try a D8. Now, remember, for a D4, we folded 3 times, right? That gave us 8 equal regions. 2 to the 3rd is 8. If we want to make a D8, we need 16 regions, so 2 to the 4th is 16, which means 4 folds should get us to the desired result. So let's start with our paper. Let's fold it once. Let's fold it twice. Let's fold it 3 times. And then a 4th time. Cut it up, and we get a D8. 8 lines of reflection, and then the angle of rotation, 45 degrees. Let's do this using the app. So that's 1 fold. That's 2 folds. That's 3 folds, and ooh, careful here. 4 folds. Make some cuts. Open it up, and you see we've got a beautiful D8. Now, you may have noticed that we went from a D1 to a D2, and then we just skipped to a D4. What happened to D3? Well, let's think about now how we would get a D3. That means we're needing 6 equal regions. So that means we need to divide the 360 degrees into 6 equal regions, which would be 60-degree angles. Now, we can't get to a 60-degree angle by folding the paper in half, right? That means we would need to fold it in half and then in thirds, because 6 is not a power of 2, but 2 times 3. So let's start off with our paper. This, by the way, if you have a protractor, would make it a bit easier, but we could fold in half. And then now try to fold in thirds. Okay, so I'm going to do my best here. Figure something like that, and then cut it up. And lo and behold, we get a D3. So 3 reflection lines and 120-degree angle of rotation. Okay, so let's do this digitally, starting with a fold in half, and then a fold in thirds. And then let's cut it up. And open it up, and we see we've got a D3. Okay, now I think we're finally ready for a D6, which is the actual shape of snowflakes, or I should say approximate shape of snowflakes. So for a D6, we want to have the region divided into 12 equal parts. So what we could do is the same steps for a D3 and then fold it once more in half. So starting with our paper, we'll fold it in half, and then in thirds, and then in half. Okay, so that's going to give us, right, 2 times 2 times 3. That's 12 regions. Cut it up, open it up, and lo and behold, we have a snowflake, right? That's a D6. Let's do this digitally. So starting with a half, and then we want to go into thirds again. And that doesn't look so great. I'm going to back it up a second. Let's try that again. We don't want to fold over. Maybe that's a little better. And then fold in half. Okay. And then let's cut it up. And open it up, and we should get an approximate D6. So 6 lines of symmetry and the angle of rotation of 60 degrees. Nice work, everyone. So we made a D1, we made a D2, We jumped to a D4, then a D8, and then backed it up a bit and went to a D3, which helped us to understand how to make a D6, which is the symmetry that we see in snowflakes. These examples were all from the dihedral symmetry group, which is both rotation and reflection symmetry. In the next couple of problems, we want to look at just cyclic, so only rotational symmetry. Now think about how we would just achieve rotational symmetry. So take a few minutes to think about it, and then you can pick up with question 7 on the handout.
So this was the handout, and it goes through those steps, and then it gets into the making cutouts using paper discs. So by folding the circular part into a cone and then cutting it out that way. I want to show you what the students did, because there were some things that came up that I think are relevant. So I actually taught this class yesterday, coincidentally. This is what the students created for D1. So you see some use the app, most of them use the app, and some did by hand. And I think that went pretty well. Same goes for the D2, right? Some did the diagonals and some chose the horizontal and vertical. And then for the D3, we started to encounter some issues. Can anybody see where the issue came up? I think if you look at this one here, because the ends weren't cut off, that doesn't quite work. And I think I needed to be more clear about that. So that if you do something like this with your students, that might be something worth pointing out, is that you need to cut off the corner there. And you'll see that comes up again. So these are the D4s. I think the D4s went pretty well. I really appreciated the student who worked on paper. And then the D6s, again, encountered the same issue. If you see down here, right, that one has the corners. So I think I wasn't clear that that needed to be cut off. I did it in the video, but I don't think it was, enough attention was made or focus was made. Here are the D8s, and you'll notice there's a problem that comes up in this one. Does everybody see the issue? So the way that was folded wasn't such that the reflection lines all went through the center, which is something that might come up if you do this in class. And that there were a couple of students that created D8s that looked like this. So they did the correct number of folds, right? They folded 4 times, but the folds weren't done in such a way that would create a D8. Okay, so that was the student work. Many of them didn't have discs, so they weren't really able to do the cyclic examples, although one had a paper plate, but they're not nearly as pretty as the snowflakes and cutouts, so I'm not going to share it with you. Okay, the second part, which I didn't get a chance to do last class because it took so long to do the first part, was on Truchet tiles. And there's some background. If many of you are already familiar with Truchet tiles, so I won't go into it, but you can read about it. And to understand why I chose Truchet tiles, they can be used for rosettes, but also to segue into frieze groups, which would be the next lesson. Also, Truchet is named after a person, and I always think that it's helpful to connect with an individual. So in addition to being a priest and a mathematician, he's also a designer, which I think my students would appreciate. Okay, so Truchet Rosette is an n by n square array of Truchet tiles. And I have this app, which was from GeoGebra. It was a tweak on somebody else's app, and it looks like this. So here the students can move these to create, depending on what n is, to create 2 by 2, for example, they would do this. And then they can switch these around by toggling. So the next part of the handout or the lesson was to create different rosettes. So starting with the 2 by 2 to create D2s, and then create C4s, and so on and so on and so on. And I think the students really enjoyed this when I've done it in person in the past. So in person, I just made printouts of Truchet tiles and cut them up and then handed them out so that they were working together in groups on the same desk, and they were like making all the different possibilities. Okay, I think we're probably close on time, so I should wrap up. I think interesting to point out that as the symmetry becomes simpler, there are more possibilities, and you see it grows pretty quickly. So this table, as well as many of these images, were taken from this paper over here, just to make sure credit is given. And then there are extensions on Truchet tilings going to triangles, which I think is cool to see. And then also using curves instead of the diagonals. So lots of fun stuff that you can play with. All right, thank you.